Rotary endodontic instruments. Contents include introduction, classification, composition of rotary endodontic instruments, nickel titanium, components of files, motor and devices. Introduction. The technical demands and the level of precision required for the successful performance of endodontic procedures have traditionally been achieved by careful manipulation of hand instruments within the root canal space and by strict adherence to the biological and surgical principles essential for disinfection and healing. To improve the speed and efficiency of the treatment, recently there has been a resurgence of mechanized or automated systems for both the preparation and sealing of root canal systems. Rotary shaping instruments are replacing the conventional hand file systems to enhance the shaping ability of the canal and reduce clinical misshapes like blocks, ledges, transportation and perforation. When the clinician masters the method of using products of rotary shaping instruments, unpredictable file breakage, metal fatigue, loss of cutting efficiency, variation in length, diameter, and curvature of canal can be avoided and better shaping of the canals with deserved taper will be achieved. Classification. Generations of motors. First generation motor without torque control. Second generation motor with torque limiter. Third generation motor with simple torque control. Fourth generation motor with apex locator and torque control. Rotary handpiece. There are three types: micromotor handpiece, reduction gear handpiece, vertical stroke handpiece. Classification of rotary instruments. Low speed rotary instruments, which includes gates, Glidden burrs, piezo instruments. Rotary instruments for canal preparation. History of rotary endodontic instruments. Historically, carbon steel and stainless steel instruments were used for root canal instrumentation. In 1988, Valia and colleagues introduced nickel titanium files to endodontics. Since then, many night-eye file systems have been developed. Rotary night-eye instruments have become popular as they can clean and shape root canals with fewer procedural errors and more predictability than stainless steel hand files. Nickel titanium. Reversible rearrangement of the nickel and titanium atoms at the molecular level. A new endodontic file is composed of nickel and titanium atoms arranged in a body-centered cubic lattice structure. Night-eye alloys are unique in that applied stress causes a called the austenite phase. When this file is placed in a curved canal, the atoms rearrange into a closely packed hexagonal array and the alloy is transformed into the more flexible martensite crystal structure. This molecular transition enables these files to bend easily and around severe curves without permanent deformation. Difference between nickel titanium and stainless steel. Nickel titanium. Excellent flexibility, conforms to canal, transports canal, plastic deformation. Stainless steel, less flexible, straightens and curvature, permanent deformation. Advances in nickel titanium metallurgy. M-wire night-eye, developed by Dentsply Tulsa Dental Specialties. Advantage: this material has greater flexibility and an increased resistance to cyclic fatigue when compared to traditional night-eye alloys. Orphase night-eye, developed by Cybron Endo. Advantage: files have reduced stiffness and more fracture resistance compared to standard night-eye files. Controlled memory night-eye. Advantage: files have superior cyclic fatigue resistance and increased torque strength over traditional night-eye files. Disadvantage includes low energy efficiency, poor fatigue properties, expensive materials, low operational speed. Components of a file. taper, flute, land, helix angle, rake angle, pitch, cutting edge. Dynamics of rotational motion. What is rotating movement? Spin in one direction and are flexed against canal walls for an efficient milling action while being withdrawn. Typical operating speeds are 150 to 500 revolutions per minute. Definition: when a particle or particles of a rigid body move in a concentric circle round a common center, the motion is called rotational motion. Radian. It is defined as the angle subtended at the center of a circle by an arc equal in length to the radius of the circle, that is, theta in the diagram. What is angular velocity? The angular velocity of a rotating particle is defined as the time rate change of angular displacement. Angular velocity equals theta by time. What is angular acceleration? Angular acceleration of a rotating body is defined as the time rate change of angular velocity. Angular acceleration equals angular velocity by time. What is RMP? The rotational speed is expressed in revolution per minute, abbreviated as RPM. If n be the RPM, then in 1 minute there is n complete revolution. For one complete rotation, it takes 60 by n second. Relation between torque and acceleration. Rotation of a rigid body. A rigid body means a body in which the distance between each pair of particles remain invariant. What is torque? It is the sum of moments of a force acting on the particles. Torque acts in a rotational manner. Importance of speed. Speed refers not only to revolutions per minute but also to the surface feet per unit that the tool has with the work to be cut. In endodontics, speed varies from 150 to 40,000 rpm. Greater the speed, the more the cutting efficiency. But at higher speed, there are more disadvantages such as loss of tactile sensation, breaking of instruments preceded by flute distortion, change in anatomical curvature of the canal, loss of control. Importance of torque. According to Merzouk, torque is the ability of the handpiece to withstand lateral pressure on the revolving tool without decreasing its speed or reducing its cutting efficiency. Torque is dependent upon the type of bearing used and the amount of energy to the handpiece. Torque is another parameter that might influence the incidence of instrument locking, deformation and separation. Theoretically, an instrument used with high torque is very active and the incidence of instruments locking and consequently deformation and separation would tend to increase. A low torque would reduce the cutting efficiency of the instruments and instrument progression in the canal would be difficult. Conventional endodontic motors to recent motors use a wide range of speeds of 150 to 40,000 rpm, which are either controlled by electrical or air-driven instructions handpieces. What is RMP? The rotational speed is expressed in revolution per minute, abbreviated as RPM. If n be the RPM, then in 1 minute there is n complete revolution. For one complete rotation, it takes 60 by n second. Motors and devices. Newer motors have been developed for rotary instruments since the simple electric motors of the first generation in the early 1990s. Electric motors with gear reduction are more suitable for rotary night eye systems because they ensure a constant RPM level. However, they also deliver torques much higher than those required to break tips. New advancements of devices. The Midwest Stylus electric handpiece system includes a motor, tubing, and remote controller. Available attachments include a red 1:5 attachment for high speed work, a blue 1:1 attachment for low speed work, and a green 10:1 attachment for rotary endodontics, and a straight 1:1 attachment for trimming, adjusting, prophy, and other uses. Thank you.